This is the video for 1.6 for function operations and composition of functions. Okay, so here are my function operations. If I have f plus g, that basically means to add the two functions together. F minus g means to subtract the two functions from each other. Fg means multiply them. F divided by g means to divide them. Then we have composition, and you did these in Algebra 2 last year, so we're going to do them again. You've got F composed with G. It's not fog and it's not Goff. F composed with G means the G goes into the F. Whatever the second letter is, it goes into the first. And then G composed with F, the F goes into the G. The second one goes into the first. The second one goes into the first. So let's take a look at our examples here for our function operations. We have f of x equals x squared plus 4x, g of x equals square root of x plus 2, and h of x equals x plus 3. So the first problem says find f plus g. So basically you do what it says. You add your f function and your g, and then you combine them if they have anything in common. Since they don't, that's my answer. And I'm just going to rewrite it so that it's neater. It's hard to do it with this pen. Okay. Then f minus h says I need to do my f minus. Now keep in mind, when you do the minus, you're going to have to distribute that. That is minus x plus 3, which means I have to distribute the minus sign to both of them. X squared plus 4x minus x minus 3. So that's x squared plus 3x minus 3. Then FH means I need to do x squared plus 4x times x plus 3. And yes, you're going to need to FOIL these out. So I'm going to do x squared times x first. That gives me x cubed. Then first outside, x squared times 3 gives me 3x. Then inside, 4x times x gives me 4x squared. And then 4x times 3 gives me 12x. So we're going to have to do all of these together. So when I combine all of my like terms, wait a minute, x cubed, oh, sorry, that's 3x squared, okay, plus 4x squared plus 12x, just double check my work. That gives me, oops, x cubed plus 7x squared plus 12x. Now I want to do h divided by f of x. So we're going to take my h of x function over my f of x function. And these, the only thing you need to do is simplify the top and the bottom in case, so you're going to have to factor the bottom just in case this has a term that cancels out. Do not do anything else other than this. You cannot cross off the x's. You cannot cross off x's here. You can't combine these here, so leave it alone. So if I want to know what the domain is, we kind of talked about this earlier. Your domain on this is going to be everything that, except for what's included in x, what makes x and x plus 4 the denominator equal to 0. So your x can't be 0, and your x plus 4 can't be 0. So your x can't be 0 and your x can't be negative 4. So you need to remove those out of your all reals. And that gives you your domain for that division problem. Let's see if there's anything else in here. Oh, there are more. Okay. Next one. If f of x equals 3x minus 4, g of x equals x squared minus 1, I want to find f composed with g of negative 3. So we have a couple different options. One is you can do f of g of negative 3. You can either plug in negative 3 into g and then that answer into f, or you can find the composition first and then plug in negative 3. I'm going to do this first because it will lead you to doing graphs. So the first thing you're going to do first is find the g of negative 3. So when I plug in negative 3, that gives me 9 minus 1 gives me 8. So now this whole thing equals 8. So we're replacing that with 8. Now we're doing f of 8. So you're doing 3 times 8 minus 4. 24 minus 4 equals 20. So 20 is your final answer. You basically put negative 3 in here and then took this answer of 8 and plugged it in here. Let's see if there's any more. Nope. Okay. Okay, another example. We have f of x equals x plus 2. G of x equals 1 over x. So I want to find f composed of g and then find their domain. So before we even start, just to do these, my domain for f of x, that's a line, is all reals. So you really have to know your parent functions in order to do these. 1 over x, if you remember your rational functions, looks like this. It's basically everything but 0. So the domain for this one is negative infinity to 0, union 0 to infinity. The reason that I want to do the domains of the original first is because I may have to refer back to them in a minute. So I want to find g, f composed of g. So g is going to go in f. So this whole function here is going to go in here. So that's going to be 1 over x plus 2. That's 1 over x plus 2x over x equals 1 plus 2x over x. That is that, okay? And if I look, my domain for this function, if I ignore all of this, if you're pretending that you don't have this problem at all and you look at this, my domain is all reals except negative infinity, except for 0, negative infinity to 0, 0 to infinity, which matches the more restrictive of these two. It matches this up here. So that is my domain, negative infinity to 0, 0 to infinity. That's what this one was originally. These two match. So when they match, you're all good. You don't have anything weird to do. However, when we get down to this example, you're going to have something weird. X squared minus 9 is a quadratic, so the domain is all reals. A square root moved 3 to the left, so its domain is negative 3 to infinity. So when it's negative 3 to infinity, okay, we're going to do our problem just like we did before. We're going to plug g into f and simplify. So square root of x plus 3 squared minus 9. So your square and your square root are going to cancel each other out. You're going to get x plus 3 minus 9, which is x minus 6. Now, if you were doing this problem without anything in the problem, that domain would be all reals because it's a line. However, if you can't put negative numbers in here, how are you going to be able to put them back in here? It's like, say you're going to the grocery store. If you go to the grocery store and don't put apples in your cart, when you get home and unload all your groceries, are you still going to have the apples? No. If you couldn't put them in the first place, then you can't put them in the end, regardless of what you have. So you have to take what's more restrictive. Whereas up here, they were the same. Sorry, my TV just came back on. They were the same, so you didn't have to worry about it. Here, they're not, because if you can't put any negative numbers, oops.
Hey, can you lift this up in there?
less than -3 in here, then you're not going to be able to put it in the final answer. So you're going to take, hold on, what's more restrictive. So my domain is going to be -3 to infinity, not this one. So what you learn from this example is you take what's more restrictive, hold on, oh, this whole thing's not moving. Okay, I don't know why this is not moving. Okay, so you're going to take what's more restrictive of the composition or the g of x. The f of x won't matter. It's only the g of x. It's only this part right here that matters. So this is the end of 1.6.